Hello, my name is Mcollins, and today I will be talking about the Notothenioid fish. So my project will focus on how the Notothenioid fish adapted to prevent their body from freezing in the cold southern ocean around Antarctica. So a little about these fish. Their scientific name is Notothenioidae, and they are a monophyletic group that plays a large role in the Antarctic ecosystems. Ecological roles that are usually filled by many types of fish in temperate waters are usually filled by the Notothenioid fish in the Antarctic waters. There are 6 Notothenioid families. So these fish live in one of the harshest climates on Earth. Antarctic waters are often temperatures around 28 degrees Fahrenheit or -2 degrees Celsius. However, this does not stop the Notothenioid fish. The Notothenioids are a group of more than 120 marine fish species that are also native to Antarctic waters. These fish comprise about half of Antarctica's marine fish species, and they also account for 95% of all fish biomass in the region. But how are these fish able to live in such cold conditions? Research has shown that the Notothenioid fish have gradually adapted to the cooler water during the Tertiary period. These fish are able to make their own antifreeze proteins in order to survive in Antarctica's southern ocean. These helpful proteins bind to ice crystals in their blood, preventing the fish from freezing in the extremely cold water. So now you are probably wondering, what are antifreeze proteins? So antifreeze proteins, also known as ice-structuring proteins, are vital to the survival of the Notothenioid fish. Antifreeze proteins are a class of polypeptides that allow an organism's survival in sub-zero environments. They are also able to bind to small ice crystals, inhibiting the growth and recrystallization of the ice that would otherwise be fatal to the organism. There may also be evidence that antifreeze proteins can interact with mammalian cell membranes to protect them from damage caused by the cold climates they must endure. But why is this adaptation important? Well, currently, a lot of research is being conducted on both antifreeze glycoprotein genes and the oxygen-binding proteins. Researchers have been able to identify the special adaptation of the antifreeze glycoprotein gene in the Notothenioid fish, but the specific origin of the proteins is still unknown. These researchers suspect that the antifreeze glycoprotein gene of the Notothenioids could have most likely evolved from the pancreatic trypsinogen. Researchers are positive that this adaptation in the organism's protein is directly linked to their environmental conditions. Oxygen-binding protein adaptations have also been impactful in aiding the survival of these fish. These adaptations include the loss of expression of the intercellular oxygen-binding proteins, hemoglobin and myoglobin. Although this may seem counterintuitive, it proves to be beneficial. The loss of both oxygen-binding proteins may be advantageous because it reduces the production of reactive oxygen species, therefore lowering the levels of oxidized proteins. Because it costs energy to replace oxidatively damaged proteins, the reduction of the hemoglobin and myoglobin proteins may reduce energetic costs. This would allow the fish to conserve energy that could be used elsewhere in its body. Thank you, and here are my sources.